Hi to everybody, and I welcome you all to today's class. In today's class, we are going to see what are the physical changes that take place in meat and the meat products during low temperature method of preservation. So in today's class, I'll be talking about the physical changes. In the coming classes, I'll be talking about the nutritional and the microbiological changes. So in today's class, we'll be concentrating on the physical changes due to low temperature method of preservation. The first physical change that we'll discuss is the shrinkage loss. The shrinkage loss during the low temperature of method of preservation, it may be in the freezer or it may be in the chilling temperature. It approximately ranges from 1.5 to 3%. Why there is shrinkage loss? The shrinkage loss is due to evaporation, is due to the loss of moisture from the meat. It is also called as an evaporation loss. Normally, if you take what is the percentage of evaporation loss in an animal that is slaughtered till it goes to the retailer, it constitutes around 5.5 to 7%. So the evaporation loss in a typical commercial distribution conditions, it has been estimated that in the case of beef or in the case of pork or in the lamb, it ranges from 5.5 to 7%. Out of this 5.5 to 7%, around 1.5 to 3% evaporation loss take place in the chiller room or in the freezer room. So next is the sweating. What the sweating denotes? It denotes the condensation of the water vapor on the meat when brought from a cold store into the ordinary room temperature. This you can also see in the display units. When the meat is kept in the display unit, which is covered like this, you can see the moisture is condensed. So what's the problem with this is that the transparency is lost, and if this moisture get condensed, it may favor the microbes and the fungus to grow. So why it is occurring basically? It is because of the variations in the temperature. So here we can see that there's a small water droplets is there, the white like dews you can see here. So you know that the air can hold a certain amount of water vapor at a particular temperature. So as the temperature decreases, the ability to hold the water vapor decreases, or the quantity of water that the air can hold at a particular temperature decrease with decrease in the temperature. So if there is a much fluctuation in the temperatures, so what happens is, or if you take this container and keep it outside of the cold room, we can see there's a moisture is condensing. It is because the dew point temperature is less, the temperature of the meat or the surface is less than the dew point temperature. So the moisture that is present in the atmosphere, it will condense on the solid surface or in the covers you can see, or in this overlaps we can see there's a condensing of fluid. So another good examples we can see is that when you put cold water in a glass tumbler, you can see the water is condensing around the glass tumbler. It is because the temperature of the glass tumbler is less than the dew point. So the water in the surrounding will start condensing on the glass. The same thing is also happening here. So how we can reduce is that we should not frequently open the freezer room or the chiller room should not be frequently opened. So if you keep on frequently opening, there's the fluctuations in the temperature, so that it can lead to sweating or the condensation of the fluid you can come across. Another thing is the gap between the food materials and the overwrap should not be much, or there should not be much air space. Okay, you can see there is a lot of air space here. So in this air space there will be moisture and it will be condensing. So that can be avoided. So the third condition is the WIP, drip, or the purge loss, or the thaw loss, or the press loss. Generally, the red fluid that comes out of the red meat from the fresh meat is called as a WIP. The red fluid that we see here that comes out of the frozen meat upon thawing is called as the drip. And the red fluid that comes out of the vacuum packed meat upon thawing, it's called the purge loss, or the thaw loss, or the press loss. So the same terminologies, the term things we'll be using depending upon the conditions. Okay. So what is drip? The reddish exudate which comes out of the frozen meat upon thawing. So upon thawing, we can find there is a lot of fluid, the red fluid will be coming out. This red fluid is called as a drip. So this fluids will contain lot of proteins, amino acids, water soluble vitamins, particularly the B vitamins. So most of the nutrients will be lost if the drip loss is more. So we can see here the drip or the purge loss. The drip loss is the loss of flavor, because most of the water soluble constituents will be lost, nutrients will be lost. Upon thawing is called as a drip. So what is the problem with the drip? So since there is a lot of fluids that comes out of the meat, the original texture will be lost. So a lot of nutrients is lost and the flavors will also be lost. Since there is a lot of moisture loss, the juiciness of the product will be lost. So since in the cover we find the fluid is accumulated, it will reduce the consumer appeal. Due to the loss of moisture, there will be dryness and toughness of that meat will also increase. So coming to the protein concentrations in the drip, it is around 140 milligram per ml. So 70% of the nutrients that is present, or the protein that is present in the meat itself, can be lost if more is the drip. So why it is occurring? It is because of the breakdown of the cell walls. So we have seen in detail in the freezing of the meat chapter, the slow freezing and the quick freezing. So you know that in the slow freezing, the ice crystals formed are large and extracellular, and it will break the cell walls. So upon thawing, the nutrients, or the along with the water that is present in the meat, comes out. So we will see that it is more in the slow freezing compared to the quick freezing. So we can see the comparisons here. So this is a quick freezing. You can see the color of the beef. You can see the difference. This is slow freeze. Chicken, you can see. Here you can see the ice crystals, the small white. You can see the ice crystals formed are mostly intracellular and small in size, so they are not breaking the cell walls. Here you can see the ice crystal formed are large and the cell structures are lost. You can see the cell structures here are intact. Here the cell structures is lost because the ice crystals size keeps on increasing and it will be breaking the cell wall. So it's very clearly, you can see here, this is the food cells before freezing. So after the quick freezing, so you can see there is a small ice crystals are formed, that white droplets you can see. This is a small white droplets you can see. It is in the quick freezing, you can see it is small and mostly intracellular. But in the slow freezing, it is large. You can see this white is very large. It is extracellular and the cell structures is lost, or the cell walls are broken. So all the content that is inside the cell will ooze out upon thawing. So the red fluid that comes out of the meat is nothing but the drip. So this drip will containing lot of nutrients, the flavor components, amino acids, vitamins, the proteins. So if the drip is more, the nutrient loss will be more. So in the slow freezing, we know that the drip is more compared to that of the quick freezing. So how to avoid the drip? So the best is avoid freezing preservations. But when you avoid freezing preservations, you cannot store for a long durations. So if you want to reduce the drip loss, you have to do the quick freezing. So in the latest technology is that they're using what is called as a flash freezing. So this is the fastest freezing technology where the meat or any food materials is dipped in minus 20 to minus 35 degrees centigrade in the alcoholic fluids or alcoholic fuels, we can say, like propylene glycol or liquid nitrogens and such things. So that is already I explained this in the methods of freezing in our last class. So another is a 3D freezing. 3D freezing is also called as ACVCS, that is anti-cycle vibration cold system. And I'll repeat, anti-cycle vibration cold system. So this is another method of quick freezing which helps us to reduce the drip loss. It helps to maintain the flavor, juiciness, the texture, and everything can be maintained by using the 3D freezing or what we call as ACVCS freezing. So here, how it is different from the other method of freezing is that it freezes from all directions at the same time. The freezing takes place at all directions. Say, suppose this is a fruit sample. The freezing takes place from all directions at the same time. So it is evenly frozen. Freezing of the content of the food material will be taking place. So here you can see the conventional freezing. So we can see there is a 5 steps is involved here. The first step is heat exchange at the fin coil. So you know that the fin coils will be there. So there will be heat exchange will be taking place. Then the cold air will be steered. A fan will be rotating and it will be steering the cold air. Then sending the cool air forward. The cool air goes here and the hot air will be returning back to the fin coil. So here I can see the step 4, returning of the hot air. Against it comes here and it will be moving. This is what happens in the conventional freezing or non-anti-cycle vibration cold system. In the 3D freezing, we can see here the air will not go to the fin coil. Only you can see here you can see from here the steering of the air take place, and the cold air will be blown in a wide range. So the freezing takes place from the all directions. So the freezing will take place evenly. Even freezing of the food content will be taking place. So that is the advantages of going for 3D freezing. So this technology is one of the latest technology. Now it is adapted in the meat industries as well as in the food industries for freezing. So this helps to reduce the drip loss. It helps to maintain the texture, the flavor, juiciness of the product. Another thing is, don't cut the intact carcass or don't cut the chunk of meat into small pieces and then don't go for freezing. The smaller you cut it, the surface area will be increasing and the drip loss will also increase. So it's better to keep a chunk of meat or you go with the carcass, and then when it is required, you can cut into small pieces. So that is way also we can reduce the drip loss. And some researchers shows that the feeding of vitamin E and lysines in the poultry will also help to reduce the drip loss. So in the case of poultry, it's a major issue. That is, when you cut the poultry carcass into small pieces, the drip loss in the poultry is very high. Okay, so a lot of researchers shows that the feeding of vitamin E and lysines will also help to reduce the drip loss. So next physical change that we can come across is the loss of bloom. So here you can see the red cherry color, that is the combination, when the oxygen combines with the myoglobin, we know that it forms oxymyoglobin, where the iron is in the ferrous form. And when there is no sufficient oxygen, or the oxygen partial pressure ranges from 1 to 1.4 mmHg, then there is formation of metmyoglobin. So if there is no oxygen, sufficient oxygen, then it forms a brownish color, which is not attractive, and the consumer always assume it is spoiled. Okay, it is because of the formation of what you call as a metmyoglobin. So here the iron is in the ferric state, Fe3+, here Fe2+. So loss of bloom. So let's design what is bloom. Bloom is defined as the color and general appearance of the carcass of the meat surface when viewed through a semi-transparent layer of connective tissues. Connective tissues, meat and fat, which form the carcass. So generally we say that bloom is nothing but the bright cherry red color of the meat, because when the myoglobin combines with the oxygen. So we'll be losing the blue because of the dehydrations that take place during the freezing, undue oxidations, and it can be prevented or can be avoided by preventing the fluctuation of the temperature. The common issues in the meat sectors that we come across is that the outer color will be cherry red in color because the oxygens will penetrate to the outer surface and it combines with the myoglobin, so it forms oxymyoglobin. So when there is a more concentration of oxygen, it forms oxymyoglobin. So below that layer, we can find there is a brown color. That is the middle layer, which will be somewhat brown in color. It is because of the oxidized myoglobin. Okay, when the oxygen concentration is low, that is, it ranges from 1 to 1.4 mmHg. Naturally, it forms what is called as a metmyoglobin. So it is brown in color, and it's very difficult to convert this brown color to cherry red in color. And we come across another conditions, that is the purple color. So here it is deoxymyoglobin. Again, the iron here it is in the ferrous form. Here it is occurs because when the oxygen concentration is very low, that is less than 1 mmHg. Okay, so that is what we do in the vacuum packaging. In the vacuum packaging, we convert the myoglobin into deoxymyoglobin. Okay, and when this deoxymyoglobin, where the iron is in the ferrous form, when it exposed to the oxygen, it forms oxymyoglobin. So this conditions we commonly come across in the meat industries also, or the consumers may be complaining that this is a spoiled meat. So this is a condition we can see this. When you keep the covers one over the another, for example, when you keep in the tray and you keep the one cover over the another, in the bottom, we can come across this color changes. Okay, somewhat blackish or dark brownish in color. Because when we keep one cover over the another, there is no sufficient oxygen transmission take place. So there it forms what is called as the metmyoglobin. So the metmyoglobin will form a brownish or black, somewhat, if you keep it for a very long duration due to dehydrations plus oxidation of this myoglobin, we get what we call as the brown color or reddish, or we get somewhat blackish in color. That is because of the metmyoglobin. So this is the problem when you go with the freezing. So we have to see that covers are placed properly, especially in the case of red meat. White meat, it's not that much issue because myoglobin content is less. So otherwise the people used to come and complain. Even in the meat technology, once in a while we get such complaint telling that meat is darkish brown or black in color, and they say it's spoiled. Like, then we used to explain them it is because of this only. When there is no sufficient oxygen, we can come across such conditions. So it reduces the consumer appeal. When it forms the metmyoglobin, it reduces the consumer appeal. That is the issue. So another condition we can come across, or it's a problem in the poultry industry, is the black bone syndrome or the bone darkening. So this is a condition we come across mainly in the young poultry birds, that is in the broilers. So let's define. It is defined as a condition where the surface of the bone and adjacent muscle tissues became dark, reddish brown or black after cooking. So this is mainly seen in the young poultry around the long bones, especially the tibia bones, around the tibial bones. From the bone marrow, the blood cells will be coming out to the surroundings. So when you cook it out, it forms hemoglobin, which gives a dark brownish or blackish in color. So the people thinks it is a spoiled conditions. Okay, this is a big issues now the poultry industry is also facing. So here there's a leakage of blood in the proximal end. From the proximal end, there will be a leakage of blood cells just below the growth plates. So let's see the mechanism, how it is occurring. So we have studied in the anatomy department, during the anatomy courses, there's the osteoclast and the osteoblast. So you know that there's a periosteum. So this is the periosteum, which is an organic layer overlying above the mineralized bone surface. So this is a mineralized bone surface, that is a cortical, and this is the periosteum. So here we generally form the osteoblast. So you know that osteoblast is responsible for the mineralization of the collagenous bony matrix. So osteoblast is the one which is found in the new bone formations. So in the new bone formation, mostly it is osteoblast, and this osteoblast will help in the mineralization of the bones. Okay, and we have the osteoclast. So we have the osteoclast are responsible for the aged bone. So it is normally found in the aged bone. So this is the aged bone. This is the new bone formations. Okay, new bone surface formation. This is the aged surface. You can find it. So here the osteoclasts are responsible for the aged bone resorptions. Okay, and the osteoblasts are responsible for the new bone formation. So periosteum covering the outer bone surface, already we discussed, is found in the outer bone surface and contain the osteoblast, which produce the cortical bones directly. So this is helping the calcified bones. Okay, so a balance should take place during the new bone formations and the resorptions. Okay, if that balance is not there, the bones became more porous. So let's see, the formation of bone on the outer surface is accompanied by the resorption of the bone on the inner surface. So first the bone will be here. What happens is the osteoclast is make the bone resorptions. So what is bone resorption? Bone resorption is the process by which the osteoclast break down the bone tissues. So it will break down the bone tissues. This process is critical in maintenance of the blood calcium levels. So to maintain the blood calcium levels, which is indirectly involved in the ossifications of the bone or the depositions in the bone. So if there should be a balance should be there. So osteoclast will help in the bone resorptions. So you understood what is bone resorptions? It is nothing but the breakdown of the bone tissues to maintain the calcium level. So initially the bone will be like this diameter, like it keeps on increasing. The bone diameter will be keep on increasing, so that the bones widens as the expanding ring of bones. So like a ring, it will be keep on increasing, and the bone marrow size will keep on increasing. So it will be in the initial it will be small. As the age increases, or in the case of poultry, the broiler birds mainly, if the bones marrow keeps on increases as the number of weeks or the age increases. So you can see here The osteoclast tried to fill in this pores. So you can see there is a lot of spores. So the mineralized bone is stained. You can see there is a lot of spores here. That white thing is the spores. The osteoclast tried to fill in this pores but failed to do so before they are overtaken by the bone resorptions. So the bone resorption process will be faster here, but the calcifications or the calcium deposits will not be that fast, or there is no balance will be taking place. Why it is occurring? The degree of porosity. So the degree of porosity, you can see the small holes. The degree of porosity has been increasing with continued selection of broiler genotype for fast growth. So when you are going with the selective genotypes, what is the drawback that we find is that it is becoming, the bone porosity is becoming more and more. So the rapid bone formation in the modern broilers is resulting in inadequate mineralization of the bone. So there is no proper ossification of the bone is taking place. So as the result, what happens? You know that the blood cells are formed in the bone marrow. So it will start escaping through these pores. This is mainly taking place during the freezing. The blood cells are pushed through these pores and it comes to the periosteum regions. So here you can see the bones. You can see this is a bone structure. See, you can see this is a periosteum. This is a periosteum, and you can see the mineralized bone is stained light red. So this mineralized bones, this light red in color is the mineralized bone, and the blood cells from the marrow. So this is the are stained dark red. So this dark red you can see, this is the blood cells, and this light red color is the bone cells, and you can see there is a lot of pores are there. Okay, through these pores, this white color pores, the blood cells will come to the surface. Okay, so it comes to the surface. So in the broiler birds, this is a growing issue now we find in the poultry industry, because there is a incomplete ossification of the bone. The blood cells come out of the bone marrow and it comes to the surface. So here you can see the red color. You can see this red, the blood cells coming out of the bone marrow, and the surface you can see it is red in color. So here the improper intramembranous ossification is one reason. We have seen how it is occurring, the mechanism we have seen. And they also say that the poor broiler welfare during rearing will also influence these conditions. The freezing process forces more blood from the marrow through the bone and into the adjoining meat. So the blood during the freezing, what happens is it forces the blood from the marrow to the bone surface, and it comes to the adjoining tissues also. So this is mainly seen in the long bulls, especially in the young birds, that is in the broiler chicken, because you know that broiler chickens are slaughtered at a very young age of 5 to 6 weeks or 7 weeks. So, and further, the cooking converts the hemoglobin to dark met hemoglobin. So the denaturations of the hemoglobin will be taking place. So microbiologically, there is no issues. Only it will affect the sensory appeals. So the people feel that it was somewhat spoiled. So the black bones and the meat after freezing and cooking, you can see this is the conditions you can see. So even in the KFC and in some chicken, when you go and take that chicken leg pieces, and inside you can find this red fluid, the red blood cells are there. Is it clear? So this is emerging issues, or this is a problem in the present poultry industry. So you can see here the study was done, and it's seen that the lightness value. So they can see the lightness value 37.5 to 40. It is acceptable. When the lightness value is in this range, it is non-significant. But when it comes below this range, 34. When it comes below the range of 34 and 37, you find the lightness values in this range, it is not acceptable. So in these conditions, there is a dark blood cells you can see on the surface. The consumer's appeal is lost. So again, you can see here the blood cells on the surface below the periosteums, and further it comes to the adjoining muscles you can see. Okay, so this is more severe in the freezer storage than in the chiller storage. It is more severe in the younger birds. It is not much noticed in the aged or the old birds because there is a complete ossification. In the case of younger birds, there is no proper ossifications, so the blood cells will ooze out. The color changes to dark gray or brown along the long bones. So that is what I shown here. So along the long bones, like this tibia bones, we can come across this thing in the sometimes in the femur also. So in severe cases, the black color, that is met hemoglobin. So when you cook it out, it gives a black color or darkish brown in color. So how to prevent these conditions? So what we can do is storing at a temperature at minus 10 degrees centigrade after partial cooking will help to prevent these conditions. So some studies is still going on that try to reduce these conditions by feeding vitamin D. So vitamin D help to favor the calcium deposits in the bone at a faster rate. So they are feeding vitamin D to the poultry rations, to reduce these conditions. So next is the freezer burn. Why the freezer burn is occurring? So before understanding the freezer burn, let's understand what is sublimations. So you know that sublimation means the conversion of the ice. You can see the ice directly into the water vapor. Okay, without undergoing the intermediate stage of liquid stage. Is it clear? So directly from the solid, that ice, it directly goes to the vapor. So that is called as sublimations. So sublimation from the surface of the food occurs because the vapor pressure of the ice at the surface of the food or the meat is greater than the vapor pressure of the water in the air. So you know that the moisture will be containing the water and the ice. The vapor pressure of this ice on the surface is greater than the vapor pressure of the water in the air. So what happens is the ice will be start escaping and it will be going as a water vapor. So you can see this as a water vapor. So that is what happening in the sublimations. So what is freezer burn? The sublimation from the surface of the frozen chicken or the meat causes air pockets to develop. So we have seen that the ice crystals are formed during the freezing. We have seen these ice crystals will be directly converted into the water vapor. So the air pockets will be developed. So once the air pockets develop, it forms a honeycomb-like structure that result in increasing in the surface area. The surface area will be increased because the air pockets will be there. So since there is an increase in the surface area, the exposure to the oxygens will be increased and that can lead to the rancidity. So let's see how the freezer burn condition will be affecting the muscle tissues. So the muscle tissues became soft and spongy. So it became soft and spongy. There is a dehydration because of the sublimations. So it dries the product and the meat appear grayish brown spot. So dry and yellowish patches with the leathery looks will be there. So it is the final stage, it became somewhat grayish brown spots or the yellow spots can be seen and it will have a leathery appearance like. This is severe cases of freezer burn. In the initial stage, we can come across the somewhat light or white or light yellow in color, and that condition is called as a freezer scorch. Okay, so here the ice crystal meat became bitter in taste. So I told you because of the increase, there is a sublimations of the water, the small air pockets will be formed. Okay, and surface area will be increased. So since the surface area has increased, the exposure to the oxygen will increase. So it can lead to oxidative rancidity, especially in the meat which is having more of fat. Okay, and this condition is mainly seen in the light colored skin, especially in the chicken and the fish. You can come across this type of conditions. So the ice crystal formations makes the meat to shriveled and dry. So ice crystal formations, you can see there's a ice crystal formations will be all there. And because of that, it gives the surface will become somewhat leathery, shrivel and dry. So it gives a burnt appearance or the burnt look. That is why it's called as a freezer burnt. So you can see it's look like a burnt surface line. So this process, the freezer scorch, is a reversible process. So again, if you do put it in the water and it can rehydrate, but once it comes to the complete freezer burn conditions, it is irreversible changes. You cannot bring back to the normal conditions. You cannot rehydrate it because the proteins will get denatured due to the rehydrations, due to the dehydrations, and the rehydration is very poor. So if you say the microbiological quality, it is safe. So safe to consume from the microbial perspectives. From the microbial perspectives, it is safe, but it has a very poor eating quality because of the oxidative rancidity. What happens is it gives a bitter taste. Another thing is it loses the texture because of the evaporation of the moisture. There is the texture is more leathery like. It will not have a proper meat texture. The color will also changes from red to brown, so the consumer appeal will be lost, or sometimes it became yellowish, spongy like it will come. And there is a oxidation of the red colored pigment, that is myoglobin, to the brown colored pigment, metmyoglobin, will also be taking place. Oxidations will also be taking place. So this is a normal color of the meat, and you can see this is the freezer burn conditions. Okay, as it goes and goes, if you keep it for a long durations in the freezer, what happens is it leads to the without proper covering. Okay, without proper covering, and if there is a dehydration taking place, or more is the sublimations, it comes into a leathery conditions like, or a burn condition we will see. That is called as a freezer burn conditions. So let's see the mechanism, how it is happening and why is the moisture lost. The moisture is lost from the surface of the frozen meat via sublimation. So we already seen the vapor pressure of the ice is more than the pressure on the air. So there is a sublimation take place. Because of the sublimations, there is a dehydrations. So here the ice crystals on the surface sublimate and leave behind tiny cavities. So already I told you it forms small pockets, tiny cavities. So since the tiny cavities are formed, the surface area will increase, so that will favor the oxidation. So that can lead to rancidity. This tiny numerous cavity increase the surface area of the meat, that's what I told you, and expose more tissues to the air. So since it is exposing more tissues to the air, it can lead to the rancidity and you can find the bitter taste. So here conditions, when there is no cover, okay, if you are not preventing the loss of moisture, the equilibration or the saturation vapor will not be attained. So the moisture will keep on lost. The moisture will keep on, there will be a loss of moisture from the surface and the freezer burn conditions will be very severe. If you have a proper cover that can prevent the loss of moisture, the freezer burn condition can be controlled because it attains the saturation vapor point faster, and there is no further loss of moisture will take place. So that's what I shown here. Again, the same thing, solid, the cover, so it comes back, it condenses, again it comes here. But here the moisture keeps on lost when there is no cover. So how to prevent the freezer burn conditions? The water impermeable plastic wrapped tight around. So you see that it is packed the air very tightly, and see that the cover or the polymers that we use will not allow the moisture to loss from the surface. Okay, it should be impermeable to the moisture loss. That is how we can prevent the freezer. Without putting in the cover, we should not keep it in the freezer. So that is what it said here. Cover me, the meat is said, cover me with the water impermeable plastics or the polymer, so I will not dehydrate. So without the cover, never keep the food materials in the freezer, because otherwise it can lead to the freezer burn conditions. This will take not only in the meat, it will take in almost all the food materials. So that type of food will be very dry. Sometimes we can come across the bitter taste, especially in the meat and the fish, it will be somewhat bitter taste. Okay, it will lose the texture, it will lose the juiciness. So it should be prevented. So whenever you keep any food material in the freezer, pack it properly and pack with such a polymers which will not allow the moisture to lose from the food materials. So other things that we can come across is the effect on tenderness. So most of the things, all these things we already discussed in the class of electrical stimulations. So you can go through that one to understand better. So I'll be just explaining this in very short in this lecture. So heat shortening, we know that why the heat shortening is occurs. when the temperature of the muscle is above 35 degrees centigrade at the onset of rigor. You know that rigor mortis take place at pH 6. At the onset of the rigor, if the temperature of the carcass is above 35 degree, then it can lead to this problem, that is heat shortening. So it is well explained, it is already explained in detail in the electrical stimulation. So you can go through that one. So what is the problem? It leads to toughness, excessive drip, and pale meat color. Because of the loss of fluids, the color will become more pale. Okay. Then what is cold shortening? This is also we are discussed in detail in the electrical stimulation. When the pre-rigor meat is exposed to temperature less than 15 degrees centigrade. Pre-rigor means which has not gone into the onset of rigor, that is its pH is more than 6, then if it is exposed to temperature less than 10 to 15 degrees centigrade, we can come across the cold shortening. So why? There is excessive release of calcium ion from the sarcoplasmic reticulum in the presence of ATP. So we have talked about this in detail in electrical stimulations. So you can go through that. So what is the problem again with the cold shortening is that muscle shortening more than 40%. So muscle shortening will be more than 40%. So it became very tough. This is irreversible. So on cooking you find this meat is very tough. Again, there is excessive drip loss. So when the drip loss is more, the nutrition losses will be more, and the meat, because of the loss of myoglobin, which is water soluble, the meat may become pale color. So so again the cold shortening, how we can prevent this? Factors leads to cold shortening: chilling of the pre-rigor meat below 15 degrees. We already seen. This is mainly seen in the small carcass size. So it will chill very fast to less than 15 degrees centigrade. So that can lead to cold shortening. Then fast air movement. Again, if the air movement is very fast, again the chilling will be faster. So that can also lead to cold shortening. Again, you can see the contraction is around 40 to 60%. So if suppose if it's 100 centimeter means the meat when it attained the cold shortening, it becomes to the length of 60 to the muscle fiber length will become 60 centimeter to 40 centimeter. So short, the active myosin will be very close. So we find that meat is very tough. So how to prevent this thing? As a thumb rule, delay chilling. That is, as a safety measure or as a thumb rule, it is recommended that any part should be chilled, any part of the carcass or the meat should be chilled below 10 degree for at least, should not be chilled below 10 degree for at least 10 hours in the case of beef and lamb. So you never chill the carcass or the meat to less than 10 degree after slaughter, at least for 10 hours. In the case of pork, it is 5 hours. So that we can avoid the cold shortening. Another is using the electrical stimulation. I think it is already discussed in detail in the electrical stimulation. Thaw rigor, again, we have discussed in the electrical stimulation. So here the pre-rigor meat, we do freezing. Then upon thawing, during freezing, nothing will happen, or in the freezer room, nothing will happen. But when you take the frozen meat and upon thawing, we find thaw rigor will be taken. The shortening of the meat will be taken. For example, this is 100 centimeter, assume this is 100 centimeter. Okay, this is 100 centimeter like. You can see the meat has become shortened. The meat has become shortened like. Okay, so it will become very short like. The drip loss will be very high. The temperature is rise through the danger zone. So in the cold shortening, it goes through the danger zone. It comes down. Here it rises to the danger zone. Temperature will be rising to the danger zone. So we can come across this thaw rigor. Thaw rigor is more severe than cold shortening. Here the contraction is around 60 to 80%. Suppose I say length of the muscle fiber is 100 centimeter before before muscle contraction means. After thaw rigor, it will reduce to 40 centimeter to 20 centimeter. Okay. Here the drip loss is also very high. So improper chilling or freezing will affect the texture, or it will affect the tenderness of the meat. So the chilling or freezing should be carried out properly. Only after attaining a pH of less than 6, you can go for chilling or freezing, 6 or 6.5. Before that, you do not do the freezing or chilling. Otherwise, we can come across cold shortening or thaw rigor also. So thank you very much for listening. Take care. In next class, I'll be talking about the effect of chilling and freezing on the nutritional and the microbial qualities of the meat and meat products. Thank you once again. Take care. God bless you all.